Hello, good afternoon. CTS265, Section 840 students for the fall 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP route course, and this afternoon's video tutorial is going to be from our Cisco Learning Labs curriculum, where we're going to be taking a look at NAT Virtual Interface. Now, I definitely want to start out by talking about traditional or classic NAT before we start to talk about NAT Virtual Interface, so that it makes sense, because I think the text does a decent job in covering the NAT Virtual Interface topic. However, I want to make sure that I compare and contrast the two versions of NAT for you, so that it's kind of a little more clear as to what the use case would be for NAT Virtual Interface. So this is classic NAT. Where we say that we have an inside domain, right? And consider this to be your LAN, right? So we've got an inside domain here, and then we've got, maybe this is an internet connection, or maybe this is just a connection out to another routing protocol or something like that internally, but you need to NAT outbound, and so this becomes the outside domain, right? So you could consider this maybe a WAN or some other remote or non-internal IP addressing, right? So I'm using a 192.168 just to keep the example simple. I mean, but I could have something in here like a 209.165.27.0/24 and say that I've been allocated a /24 by the provider, and that this is the ISP over here. Right? Now, with traditional NAT, notice that, again, it's inside and outside. And an interface is one or the other. So in traditional NAT, I can't define this as an inside interface and an outside interface. And this is where NVI comes into play. Because with NAT Virtual Interface, when we're performing NAT, it is domain agnostic. And so what that means is we simply say IP NAT enable on an interface, and that is 3 words there, so I got a little close. So IP NAT enable on the interfaces which we want to have performing NAT, or network address translation. There is no more inside domain or outside domain. It's simply the interface is either doing NAT or it is not doing NAT. And so that's one of the significant differences. The other significant, and I like to call this sort of an order of operations difference, is that when you're doing traditional classic NAT and you have traffic that's coming from the inside network, right, and it hits this inside interface where we have IP NAT inside, right? And this is the old classic. And then here we would say IP NAT outside. Again, keeping with that traditional NAT configuration where an interface can only be one of either inside or outside. It cannot be both. In fact, you'll get an error if it's configured for inside and you try to, if it's configured for inside and you try to say IP NAT outside, you're going to get an error. And if it's configured for IP NAT outside and you try to configure IP NAT inside, you're going to get an error. But here's the significant order of operations challenge that NVI is addressing. So with classic NAT, as the information here, or I've got, let's say, IP addresses coming in to the inside interface here, what's going to happen is when that traffic hits from inside to outside, what you're going to see, right, as it goes through the router, is that when the traffic is received, the classic NAT response is going to be to route the traffic first. So it's going to make the routing decision first, and we'll see this in a debug where you'll see it's going to hit the fib, right, because we have Ceph switching enabled. So we're going to route the packet first, and Ceph switching is enabled, so you're going to see it hit the fib, and then it does the NAT translation. I'll say it NATs it, right? So going inside to outside, we do the routing decision first, then the translation. Now, coming back from the outside, traffic coming back through the outside interface to the inside interface. This is where it's completely different. This is where it NATs the traffic first. So it does the NATing work first, and then it makes the routing decision, right? And again, that is classic NAT. Now, one of the challenges here is that this causes problems when I need to say something like on the outside interface here, I need to say IPNAT outside source static. If I'm trying to do a static NAT coming this way, traffic going out and then coming back in, it doesn't get routed first. It gets NATed first. And so that's a problem, and we would end up losing connectivity. And so remember, again, with classic NAT, it routes it first and then NATs it going from in to out. And then when it's going from out to in, it does the NAT operation first, then makes the routing decision. Now, this is totally different from NVI. So if I were to say NVI, NAT Virtual Interface. And so this also addresses the problem if you've got multiple inside interfaces. And so if we look over here at our diagram, you can see that we've got an inside interface here and what's going to be an inside interface here. Well, how do I NAT back and forth between two inside interfaces? Because I can't define one of them as outside. And so that is also a problem. And then I've got a small diagram here. In the documentation, the other use case, other than going inside to inside, is when you're doing VRFs, right? So let's say that this is a provider edge router, a NAT PE device, and it's got a link out here to the internet, a single link. If I've got VRFs here and here for my customers, right, and maybe I've got another customer here, another customer here, right? We've got all these VRF interfaces. None of these VRFs have visibility to the other VRFs, right? So VRF shop can't see, VRF bank's routing table on the NAT PE router, because that is the entire premise behind virtual routing and forwarding. So we're carving the router up into virtual logical slices that are mutually exclusive from all of the other VRFs. Okay, and that's how we provide security in a VRF environment. But that also causes a problem in terms of doing NAT. And so NVI in this use case here, in fact, if you were to simply Google configuring NAT for IP conservation or Cisco NAT Virtual Interface, you'd be able to find this and you could read through it. And a little further down, it'll give you some configuration examples. But this is another use case where NVI can be used to solve this complex NATing problem, right? And it all comes down to that order of operations that I keep mentioning, which is very important. And so we talked about the order of operations with classic NAT, but what does it look like with NVI? Well, with NAT Virtual Interface, when it goes from inside to outside, so when it's switching it internally in the router, it's going to, and again, it's the same irrespective of the direction. So whether it's going from here to here, and I said inside outside, I probably shouldn't say that. When it's going from this interface to this interface, we have IP NAT enable is the command. Again, remember, there's no IP NAT inside, no IP NAT outside when we're talking about NAT Virtual Interface. And so it's universal that whenever traffic hits an interface, if that traffic is to be NATed, and we'll see that you still can do static NAT, you can still do dynamic NAT, and you can still do NAT overload with NVI. But the difference is that with NVI, it's going to route the packet first to the NAT Virtual Interface, and we'll see this interface NVI 0, and this is where it does the NAT operation. And then it routes it again. So we go, the order of operations is route to the NVI interface where NAT takes place. The NAT operation will take place, and then we route it again. And that solves the problem that I mentioned earlier, specifically trying to NAT between two inside interfaces, or in that VRF scenario that we gave, this is going to allow that to take place. And this is really what NAT Virtual Interface is all about. Now, if we're dealing with a simple scenario where that's the inside of my network and this is the outside provider interface, then we can stick with classic NAT. There's no reason to use NVI because we can just as easily do classic NAT here, but it's in the more complex scenarios. And again, I gave you those two use cases, the inside to inside interface, or when we're talking about VRFs, where NAT Virtual Interface is going to play a role. And excuse me, I remember last year during the routing class, there was a substantial amount of confusion among the learners in terms of, well, is it a totally separate type of NAT, and when would I use it? And I don't understand, in terms of the routing, how is it making the decision and in the NATing portion of it. So I want to make sure that I give a much better explanation this go around, as well as some better examples as to how to compare and contrast the two and what the differences are. And so again, the two major differences. First is the order of operations in the routing and NATing decisions. With classic NAT, inside to outside, it's route and then NAT. From outside to inside, it's NAT and then route. And then with NVI, it's the same every time. It's route, goes to the goes to the I'm drawing a complete blank here. It goes to the NVI interface, the NAT Virtual Interface. Sorry about that. I was thinking national. I couldn't get national out of my head. So it goes to the NAT Virtual Interface where the NAT operation takes place, and then it gets routed, right? So it's route, NAT, route when we're talking about NVI. So let's take a look at the scenario here. And I think that the scenario, and let me cancel that, sorry. I think that the scenario also introduces a little bit of confusion, because what we're seeing here and what they're going to have us set up is, unless we've got inside interface to inside interface NATing going on, we could just as easily do classic NAT here, because that is clearly the outside interface, and these are our inside hosts. Even though they're on two separate segments here, these are the inside hosts. So let's dive into the activity, and we'll definitely continue the conversation as we move along here. So the first thing it wants us to do is it wants us to create an access list on R1. And all of our work, and I apologize here, let me switch over to Web Telnet real quickly. So all of our work is going to be focused around router 1. And then we'll make the text as large as we can. All right, so now let's jump on router 1. So there we go. So we're in user exec. Let's get into privilege exec. And we're going to just simply do an access list to match the traffic coming from the 192.168.10.0/24. So I'm going to match any traffic, and the PC would be as the only unit out here, the only node here. So if the PC traffic hits the router, we are going to set up a NAT pool for this traffic to go outbound. So let's go ahead and do that on router 1 here. We'll get into global config, and we're simply going to create an access list. So we'll say access list 1 permit 192.168.10.0 0.0.0.255, right? So very simple access list, and that really breaks down into sort of three major tasks. We create the access list, we're going to create the pooling list, and there's going to be a fourth set of tasks, or fourth and fifth you could consider, where we say IPNAT enable or IPNAT inside outside. But the three major tasks are: we get this access list done. If we're going to be doing a pool, we're going to associate the access list to the pool, create the pool, and then associate the access list to the pool. So any traffic that hits router 1 when we apply this NAT statement, the IPNAT enable, if it matches that access list, that traffic is eligible to be translated. So now we need to create a pool. And the pool of addresses that we're creating are going to be in this 209.165.201.1 address range. And let's take a look at that interface and see, do show IP interface brief. All right, and that's going to be Ethernet 02. And if I say do show run, is it a 128? Let's see what it is. Ethernet 02 is a .224. So our CIDR notation for this would be 128, 192, 224. So we're borrowing 3 bits of the host bits. We're using those for network bits so that we can subnet. So we've got a /27. So how many usable IPs are left over? Well, if I'm borrowing 3 of the 8 bits, that leaves 5 bits behind. And so 2 to the 5 is 32. And then we subtract 2. Is that right? 2 to the 5 is, let's see, 2, 4, 8, 16, 32. Yep. So 2 to the 5 is 32. We subtract 2, and that leaves me with 30 usable host IPs. So we're going to carve out a little chunk of those host IPs right now. So we're going to say IP NAT pool, and we'll name our pool NAT_pool. And we're using 209.165.201.5 to 209.165.201.10. So basically, those 5 addresses right there. Now, I can say net mask or prefix length. So, and the prefix length is nice because I can simply look at that and say, yep, that is a /27. So what we've just done is we've taken, and there you go. You can see that even before I type IPNAT enable or IPNAT inside, IPNAT outside, as soon as I create the NAT pool, we're now presented with another interface. So do show IP interface brief. We now see this NVI interface here, and it's going to assign an address to it auto-magically, right? And that's fine. And it doesn't have to be the address off of the pool interface, right? Or the address space from which we're pulling that pool of addresses. All right, so we've got the NAT Virtual Interfaces now created, NVI 0. We've created the pool, and so after we create the pool, now what we need to do is we need to associate the ACL that we created earlier with the pool. Now, remember, with classic NAT, I would say IP NAT source, and what would I say? I would say either static, if this was a static NAT scenario, or I would say list in order to identify the ACL. So remember, the ACL is matching the 192.168.10.0/24 network. So that's the network when we say IP NAT, I got to get list in there, IP NAT source list. But what's different about this command also from a classic NAT perspective? Exactly. When I say IP NAT, why am I not saying inside or outside? Exactly, because this is not classic NAT. So there is no more inside domain, outside domain. With NAT Virtual Interface, the inside-outside concept is completely wiped away. So we simply say IP NAT source list 1 and pool, and I think we called it NAT_pool, right? So I associate the internal addresses, the 192.168.10s, with the pool of available addresses. Now we're also going to create a static NAT one-to-one mapping. And again, to really take a step back here real quick, if I do a question mark here, remember, just like with classic NAT, how I can do dynamic NAT, which gives me a finite limited number of NAT addresses, and in our case it's .5 to .10, I could say overload, and I could use PAT with a pool of addresses. And then I've got 65,000, roughly 65,000 connections per IP address that can be used there. And remember, those 65,000 connections are coming from the TCP and UDP port numbers. That is how PAT, or NAT overload, differentiates the connections that are coming through the router. So we say IPNAT source list 1 pool NAT underscore pool. And again, I'm not going to use overload because they're not asking us to do that. They're just saying use dynamic NAT. Right, so there we go. We've got our dynamic NAT. So now we're going to do a static NAT. So again, IP NAT, but I'm not going to say inside, and I'm not going to use outside. And it's interesting. Remember, you're always seeing IP NAT inside, because the examples that you always see are that the NATing takes place in the inside of the network, and you're typically not doing a IP NAT outside statement. But keep in mind, you can do an IP NAT outside statement that'll perform NAT on the outside interface. But again, that's where you kind of run into some issues when that traffic is coming back, or it's actually coming back but then trying to get back out, because again, it's doing the NAT decision first and then the routing decision. But here with NAT or NAT Virtual Interface NVI, we simply say IP NAT source static, and then my static setup here is going to be between the 172.16.10.0, right, and then the 209.165.201. So again, this could be an inside interface, and that could simply be an outside interface. So let's go ahead and let's configure this up. And this is, again, it's a good activity in that it walks you through how to do the setup. However, like I said, I believe it introduces some confusion in terms of, well, what would be the use case where I would actually want to go with NAT Virtual Interface as opposed to classic NAT? Because clearly, when we look at this, you can see that this could easily be a classic NAT setup. So we're going to say 172.16.10.10, and we are going to tie that directly to 209.165.201.2, right? And you'll notice that that is not in the address pool, right? In that pool of addresses that we started at .5. Okay, so now that we have do show run section NAT, now that we have our NAT pool, our ACL tied to the pool, and our static NAT statement, and again, when we look at this, remember we're doing two different types of NATs here. Now that we have all of this, we have to determine on which interfaces do we want to enable NAT Virtual Interface, right? Or to enable NATing functionality. So we know that it's going to be Ethernet 00, 01, and 02. So first let's do this. Let's do it wrong. If I go into interface Ethernet 00, and that is going to be my, what's the outside interface here? So 02 would be outside. So this would be IP NAT inside, right? And then let's get into, and we've got to give it a second here. Hopefully I didn't just kill it right there, because it shouldn't work, but then again, it shouldn't completely hang up. And it looks like we may have broken it. So I should be able to type that and not have it completely hang here. All right, let's go to device managers. Let's manage devices here, and we are going to reload. And before we do that, let me grab all of that right there. And I'm going to copy that real quickly. So when we come back in, I can just dump this. Whoops, oh, okay, there we go. We're back. All right, so do show run interface Ethernet 00. All right, so there we go. We've got the IP NAT inside. Now, a quick note on this virtual assembly. So NAT virtual assembly is typically used when we're using, excuse me, when you're using what is called an application layer gateway. And in other words, I've got a quick link here. If you were to Google, Cisco using application level gateways or layer gateways, you'll see that it's basically when you're using things like IPsec, right? So remember, IPsec also encapsulates the traffic, and in tunnel mode, we can also put another IP header on there. And so we need to take that into account when we're using IPsec, and that's when you would get into a scenario when you would be using an application layer gateway. And so this virtual reassembly, it just makes sure that it is examining, it stalls all the packets briefly so that it can inspect things. Again, it might be a small performance impact because it's stopping the, I shouldn't say stopping, it's delaying the packets a little bit, not stopping them, but it's delaying the packets a little bit just so that it can take a look at all of the fragmented packets to make a decision, right? And that's what that virtual reassembly is. And so I want to make sure I cover that because you see that created as soon as we created the IPNAT inside statement. So let's go into Interface Ethernet 01 and say IPNAT inside, and let's hope, there we go, a little faster, and Ethernet 02 and say IPNAT outside, right? So now we've set this up as classic domain-based NAT, but all of our statements do show run section NAT. All of our IPNAT pool and source statements are wrong. So let's go over to the PC here, and let's see if from the PC, can I ping out to 209.165.202.129? So 209.165.202.129. Let's see if we can get out there. All right, and we can. So when we look at this, you can see that it's actually working even though the statements are incorrect in terms of I have NAT Virtual Interface pool and ACL statements and static statements, but I've applied classic NAT onto the router. So if I say do show IP route, let's see, you see we have a default gateway. So, but why are the packets going out? If I say do show IP NAT translations, we have none. What if I say do show IP NAT NVI translations? And it's do show, let me get into context sensitive help here. Show IP NAT NVI translations. There we go. So take a look at what happened. We've got the static entry in here, but there were no translations. So is NAT actually working? To take it one step further, if I was to say debug IP NAT detail, and let's do debug IP packet detail as well. And let's go back to the PC, and let's run that ping again. And let's come back to router 1 here. And we should see something. What happened? Did I not run that command? Yeah, we ran the command. Let's say repeat 100. There we go. Oh, and you know, so I believe it is caching everything with Ceph. So let's turn off Ceph here. Let's go ahead and turn Ceph off on Interface Ethernet 00, no IP route cache. And Interface Ethernet 01, no IP route cache. All right, let's try that again. Let's see if we can get this to work. So we'll run 100 pings through. You notice it went a little slower there, and there we go. All right, so that's what we're looking for. So here is what I'm going to do. I'm going to put some space. You can see the Type 8 ICMP packets for echo request. So I'm going to actually now, instead of running 100 packets through, let's just run 1. And let's see what happens or what it looks like when we have do you all. Let me make sure I turn off debugging here. Do you all. All right, so we didn't see any NAT translation going on, and let's take a look and see if NAT is even working. So the packet routing succeeded, and here was what I was talking about. You'll notice that fib IPv4 packet processing, route packet from Ethernet 00. So there's my source and there's my destination. And the packet routing succeeded. But do we see, right, post routing NAT outside. But do we see something telling us that this 192.168.10.10 is being NATed into an address in that range, in our range that we defined? Remember, the range that we defined was the 209.165, I believe 201. So it's .5 to .10. We know that. Do we see that? So we don't see that. And what about the return packets when they come back? Right? Because remember, the echo replies go out, and then the echo request goes out, and then the echo replies come back in. But NAT application layer gateway proxy, okay, but there is no NATing taking place here. Do you see that? So there's no NATing that's being done here. If there was, we would see statements calling out and showing. It would have like the IP address and have like a little arrow, and then show you the NATed IP address like this. And it would show that that is the IP, this is the exchange for the NATing that's going out to this IP. So this source going to that destination. But we don't see that because NATing is not taking place. So right now, with the legacy NAT statements, it's not working, and it's not going to make that NATing decision. So let's do this. Let's get into interface Ethernet 00 and say no IP NAT inside. Interface Ethernet 01, no IP NAT inside. And then interface Ethernet 02, no IP NAT outside. So we basically just cleaned up our NAT configuration, the classic NAT configuration. So now all we need to say is IP NAT enable. Because IP NAT enable is how we enable an interface that we want to do NATing based on a NAT Virtual Interface I was going to say perspective, but to take the approach of doing the NAT Virtual Interface so that there really are no inside or outside domains, right? And you'll also notice, it's interesting when we get into the show IP NAT NVI statistics and the show IP NAT NVI translations, is you're going to see it no longer says inside global, inside local, right? Or outside local, outside global. Because again, there is no more concept of an inside domain and an outside domain. It's just, if I put IP NAT enable on an interface, that interface is running NAT Virtual Interface. It's going to be doing its NATing based off of the NAT Virtual Interface order of operations, where it will route the packet. There we go. Boy, that took a while. Where it will route the packet first, sends it to that NAT Virtual Interface, the NVI interface, where it performs the NAT operation, and then it routes the packet again. So we get that on interface Ethernet 02. Let's get an interface Ethernet 00. And we're going to say IP NAT enable. And then interface Ethernet 01. And we say IP NAT enable. Now, we've got do show run section. Now let's make sure that all of our statements are there. So good. So we're ready to go. So again, the differences, and I can't stress this enough, is it's one of the major differences. We don't say IP NAT inside or outside. We say IP NAT enable. There is no more inside or outside. And because there's no more inside or outside, when I define my pool, when I define my ACL, when I define my static NAT statement, or if I had overload here at the end, when I define LOAD, when I define the dynamic or the NAT overload / PAT setup, I do not put right in there is no inside statement anymore and outside, because we don't use domain. So if you see inside or outside, you are doing classic domain-based NAT. If you do not see inside and outside, you are not doing classic domain-based NAT. You are doing NAT Virtual Interface. All right, so let's clear the palette there. And let's go ahead and say, do show IP NAT NVI translations. And so the static, and actually like to quick definition here. So you can see it says source global, source local. It no longer says inside global, inside local, and then it's destination local, So it's source and destination interface, not inside and outside interface. And we get this entry here because this is the static entry which we defined. So now let's go ahead and run some traffic through here. So let's ping, and let's go back to the 100. So we're going to ping 100 times there, and you can see we had to ARP out real quickly, and then we got our ping. And now if we say, yeah, so take a look now. So now we can clearly see that we have some entries here. We have the static entry, and that static entry will stay in here forever until we remove the static entry. And then we've got the ICMP echo. And remember, this is the 209.165.201.5. Remember that? That's that first usable IP in that range of IP addresses. So this is the source global, or what used to be the inside global IP, which is that publicly routable IPv4 address on the internet. And this is my source local IP, which used to be my inside local RFC 1918 private address in my LAN segment that is NATed out to that globally routable IPv4 address. And then we have the destination local and the destination global, which happen to be the same. And so majority of the time, or I should say majority of the time, a large part of the time, these addresses will typically be the same. But again, we see that the entry is now in the NAT NVI translation table. And the older commands, in order to drive home the point that you can't mix and match the configurations, if I say do show IP NAT translations, what do we see? What about do IP NAT statistics? Right? And that was probably when we did, yeah, when we set it up initially, it probably grabbed that information. But you can see here that this is the do show IP NAT NVI statistics, and this is the command we want to run when we're doing the NAT Virtual Interface, right? So let's do this, right? So here's where classic domain-based NAT is not going to help us out. And remember, I said if you were trying to go from an inside interface to another inside interface. So let me pull up real quickly here. Let's see, we'll do it. We can do it real quickly on router 5 actually. So on router 5, if I get into global config and I go into interface FA00, if I say IP NAT inside on this interface, it's going to take it a second, right? Because we've got to pull together our translation table. We've got to get everything ready to go with NATing here. It's doing its internal accounting. So there we are. We're back. So now if I were to say IP NAT outside, right, you can see that it changes it. But do show run interface FA00, you can see it changes it, right? But it doesn't. And what are we doing? I got a bunch of, this is probably, hold on, this is a pre-configured interface here. It looks like something was going on there. So let me say show run in FA00 over here, because one of these routers, there we go. So if I was to come into global config, interface fast Ethernet 00, and say IP address, 10.1.1.1, make it a /24, and say no shut, and say IP NAT inside. We'll give it a second, because we should see an error message here. I'm hoping that I'm not going to have to fully configure the interface. And then say IP NAT outside. There we go. That's what I was looking for. So you can see it says interface is inside enabled, right? So it's not going to let me change it. Do show run interface FA00. We've got that inside statement already there. So if I try to say NAT IP outside, I can't make the interface both inside and outside. So let's pull the inside statement off and say IP NAT outside. Okay, well, if this is my outside interface, what if I also wanted to do NATing on the inside, IP NAT inside? You can't, right? And so this is one of the limitations of classic domain-based NAT, is that with classic domain-based NAT, the interface is inside or it is outside. It is not both. And you can clearly see that. It cannot be both. Again, it's either inside or outside when we're talking about classic domain-based NAT. All right. So now what we're going to do is we're going to go back to what we were looking at, which is our diagram here. Give me a second. All right, there we go. So we go back to our diagram here, and you can see that we can't go inside to inside with classic domain-based NAT, but I can go from inside to inside when I'm doing NAT Virtual Interface, because remember, it routes the packet first, then does the NAT translation, then routes the packet again. So let's do a little experiment here. So on router 1, we're going to create a static NAT for the PC right here on router 1, but the static NAT is going to be here on this 172.16.10 segment. And we'll do the same, we'll do vice versa. We'll create a static NAT for the server and put it on the 192.168. So again, remember, I say IP NAT. Now, do I say inside or outside? I'm in an interface here. Sorry about that. I was looking at that. I'm like, where's the source? So IP NAT, do I say inside or outside? No, we say IP NAT source. So the source will be the 192.168.10.10. Let me double check that real quick. Sorry. Actually, did we use that before? What is the PC's IP? Show IP interface pair. I think it's 10.10. Yeah, it's 10.10. Okay. So now I'm going to create a NAT statement for the 10.10, and I'm going to make the address 172.16, and I apologize, I'm going to have to step back over here. Let's get on the server here. Show IP interface brief, and it's also 10.10. Okay. So, and we're going to point that to 10 dot, and I can't make it 10, so I'm going to make it, let's see, we'll do 11. Okay. And what did I forget there? Oh, static. Sorry, I forgot the static command. 192.168.10.10, and it's we're gonna NAT that to 172.16.10.11. So non-static entry already. Oh, that's right. So we've already got this do show run. I don't have a second PC either. Do show run section NAT. So we may not be able to do this. Yeah, because we've. Or wait a second. Where? Oh, is the entries already in the translation table because we did the ping outbound? Okay. So do show IP NAT or do show IP NAT NVI translations. All right, so it has what appears to be a static entry in there for the 5 on that interface, and so it looks like it's not going to allow me. Let me see if I can do clear IP NAT NVI translations. And let's get some context sensitive help here. Let's say clear IP NAT NVI translation, and I want star. There we go. Show IP NAT NVI translations. Let's see if we got rid of that. All right, we got rid of that. So now let's go back and see if we can make this happen again here. So can I do a static NAT? I can, right? So we've got the static NAT right there. And now what we would need to do is we'll do another static NAT in the opposite direction. So IP NAT source static. And this, we're already using, I have a feeling it's going to come back and complain about this, because we've set that static NAT statement that's in the table. But let's see what happens. 172.16.10.10, and we're going to put it on the 192.168.10.11. Yeah, and it's already mapped, so it doesn't like that. We've already got that static statement. But if I go to the server, remember, we got the static NAT in here, and these would be considered inside interfaces with classic NAT. Remember, both of these interfaces here, Ethernet 01 and 00, these would be my insides, because here are my private RFC 1918 addresses, and we're going out to the big bad internet. So let's see what happens. So from server, and actually, I'm sorry, let me take a look at that again. Let's see from the PC, the static is, yeah, so from the server, can I ping 172.16.10.11 from the server, because that would indicate that we're on the same subnet. So let's see if it allows me to ping it and take a look at that. But let's quickly go to the router here and let's see, do we have a new translation? We do. Do you see that? The ping command, that ICMP, wait a second. Yeah, the ICMP ping command. So we've got the destination local and the source local and the destination global. Take a look at that. Right? So here is an example of where these addresses are not going to be the same, and they are specifically not going to be the same because we created a NAT entry for the PC and made it appear as if it was on the same subnet with that NAT statement as the 172.16.10.11, the server. So when the server, which is the 1010, pings 10.11, the router knows, oh, right, I've got a NAT statement for that because IP NAT enable is on there. When the router sees the destination network here, right, and it knows it's coming from the source 172.16.10.10, it says, oh, that's right, here's my NAT statement for that. It's actually 192.168.10.10. And this you cannot do in classic NAT, is go inside to inside. It creates problems with classic NAT. So this is the real use case. If for whatever reason in the diagram here, for whatever reason you needed to start doing NATing from inside to inside, NVI is your solution. And again, you can see where when you see this, it's kind of not really 100% clear. Okay, well, we can certainly set it up with NAT NVI, right? The NAT Virtual Interface. But how is it different? How is it any different from classic NAT? And that example right there of creating a static NAT entry for the PC that made it look as if it was on that subnet, that is NVI in a nutshell. We're going between what would be with classic NAT to inside interfaces. But we can do it because, again, it routes it, sends it to the NVI NAT interface where the NAT operation takes place. And that's why, because it routes it first, right? So let me take a step back here. So the routing decision is made first. So when that packet shows up at router 1 and we're pinging something that shows that it's on our subnet, router 1 is going to look at that and say, oh, wait, I need to route that. I have an entry for this network. Then it does the NAT, seeing that, oh, yeah, it's going to go to the 192.168. The 172.16.10.11, which is the NAT definition that we made. But again, I have a NAT definition that tells me that .11 is actually the PC, right? The 192.168.10.10. So it routes it, does the NVI NAT operation, and then routes it again. And that is how NAT NVI is allowed to get away with things like I shouldn't say get away with, but to overcome the limitations of classic NAT is a much better way to express it. But that is what it's all about, right? So again, sort of frees us from the inside-outside classic NAT topology where we're forced to deal with, okay, everything here is on the inside, and everything here is on the outside. All right. So hopefully this has cleared up and give you a much better understanding and idea of a couple of things. First, what classic NAT is all about, and the inside and the outside domains, and the inside and the outside interfaces. And then NVI, which again is not a mutually exclusive technology. It is a feature enhancement to NAT to allow it to say, I don't care if it's inside or outside, NAT's enabled, NAT's enabled, NAT's enabled, because I'm going to route, I'm going to NAT, and then I'm going to route again, right? All in that order of operations is where this all becomes really, really important. And remember, with classic NAT, what is our order of operations? When we're going from inside to outside, it's route and then NAT. When it's coming back from the outside to the inside, it's NAT. Oops, sorry, I was going to spell out NAT. It's NAT and then route. And that's much different than this. All right, thanks so much for watching. I hope this has really given you a good grasp of what NAT Virtual Interface is all about and what classic NAT is all about. Enjoy your weekend, guys, and I will see you all on Monday night.